Okay, now I want to talk about the ideal gas law. What is the ideal gas law? It's a law that was invented by Avogadro, and it is written mathematically as P times V equals N, R, and T. And what those are is they are information that he gathered, and what he discovered is that whenever he was studying a system with gases, and we'll just talk about a balloon with a bunch of gas particles in it, and they're of course at a certain temperature, so they're moving around, they're vibrating, and as they vibrate they're colliding off the side of the container of this balloon. And you know that if we actually raise the temperature, the particles would move faster. The faster moving particles would have more collision would have greater pressure, and that greater pressure would then make the balloon expand and have a greater volume. And so we could even take a balloon and blow more particles in it. And if you put more particles in it, you'd have more collision, so the balloon would also get bigger. You've done that when you've blown up a balloon. You've added more particles in by breathing into the balloon. So we also could take that same balloon with the same number of particles and put it in a colder temperature, like a freezer and that kind of stuff, and the balloon will contract. Because the particles stop bouncing around as much, the pressure goes down, so the volume goes down. So all of these changes in pressure, temperature, and volume are all related to the number of atoms that are involved. So N stands for moles. And moles, we remember, is a counting unit in chemistry. It's just how many particles are inside in a molar quantity, 6.02 times 10 to the 23rd. Well, that mole number, if we know a gas, we know how many moles are in there, we can actually mathematically figure out how big the system is, how much volume it has. Or maybe the system is in a metal container, and we can then figure out how much pressure is in that container. And so, or we can figure out how much temperature. So that's how they fill tanks, like for scuba diving, for welding gas tanks. They know if they pump the gas in at a certain temperature and it gets to a certain pressure, then they've sold them so much volume of gas. And so it's really cool. This formula, or this ideal gas law, actually allows you to solve for anything in the system. And it doesn't even matter if they're small gas particles or larger gas particles. There's so much extra space that this rule or this law works for all gases. So the number of particles you have, regardless of how big the gas is, always works in Avogadro's ideal gas law. So let's do a problem with it, okay? Here we have a gas. We have a container that holds 12 grams of helium. It's under a pressure of 1 atmosphere. It is at a temperature of negative 25 degrees Celsius, so it's in a cold container. And it says, our question is, what is the volume of that container? So here we go. We're going to use the ideal gas law. Anytime they mention mass or moles, we know that our combined gas law does not have any kind of equation or symbol that deals with mass and moles, but this one does. So the little key to this whole situation of when to use which law is the idea of mass or moles. We know that if you think about our flow chart, we know that we can change mass into moles anytime. So we're going to do that right now. Let's turn this 12 grams of helium into moles so we can use it in our formula. So we know to go from mass to moles is one jump. We write down our given number, 12 grams. Helium's weight is 4. And so we're going 2 moles, 1 mole. Helium weighs 4.0 grams per mole. And so we multiply it out, we get 12 divided by 4, we have 3 moles. Okay? So now we can start our problem. And so we go here to our equation, and I've taught you before, it's real simple. Just write down your equation and then plug in all the numbers below it. So the pressure in this problem is 1.5 atmospheres. And then the volume is what we're trying to find. What is the volume? So we always place an X in that position because we can solve for it. The number of moles of the gas, well, they didn't give us moles, they gave us mass. We changed the mass into moles, so we're dealing with 3 moles of helium gas. And then we have to use R. Now, R is called a constant. They're very common in chemistry. And R are just numbers that are always repeating in the formula. And this repeating number never changes. So you can memorize it or write it down someplace where you can find it. It is 0.0821, and it has 4 units, so the rest of the units you have will cancel out. It does have moles on the bottom, kelvins on the bottom, It has atmospheres on top and liters on the top, and those are the 4 units. It's just so the one you want will be left over when you're done, okay? And then our temperature is our last piece of information we need to include, negative 25 degrees Celsius, but all gas laws, even if it's the ideal gas law, always have to be in kelvins. So we take 273 and we minus 25 and we get 248 Kelvin. So 248 Kelvin, okay? So there's our equation. We plug the numbers in. So remember, this has to be an atmosphere, so this equation is a little more restrictive. Where the combined gas law, we can use atmospheres or millimeters of mercury or kilopascals. This equation, since we chose to use this particular R value, then it says we must always do our math with atmospheres, and we must do all of our volume numbers with liters, so this is going to get a liter unit will be our answer, okay? So it's a little bit more restrictive. There are other R units if we want to use different units with that, but we're going to always use 0.0821, so you can just memorize that as the constant number that always goes in that spot. Okay? Well, we want to solve for x. How to get x by itself? Real simple. We divide out by the one we don't want, which is 1.5 atmospheres. 1.5 atmospheres. Okay? So here we go. We'll just do our math. We want to find out how big our container is. So we take 3, we go times 0.0821 equals, times by 248 equals, then push divided by 1.5 equals, and I get a final answer of 40.7 liters. And so that is the new volume of the container. So because we knew the pressure, and because we knew the temperature, and because we knew how much gas particles we were dealing with, we could actually figure out how big the balloon or container is that's holding those particles. Now if I change the temperature, it's going to make my container bigger. Because you can see that bigger number here will give me a bigger number on top. If I lower the pressure, I'll get a smaller number. So lowering the pressure will allow the balloon to expand again. So all of those changes would be captured in this equation. Okay? So that's called the ideal gas law. It's when we know the mass or the moles of a particle of gas, we can find out any other missing information if we know the other two. Okay?